reactant side if we disturb, it will move. Suppose if I increase the pressure, reactant side, it moves towards product side. Product side, because compared to product side, reactant side pressure is more. So this equilibrium try to escape from this stress. It moves where the that pressure is less. If I increase the pressure, it moves the equilibrium towards the where the number of moles are less, where the volume is less. In that way, will shift. I'll explain one by one factor. First factor is concentration, effect of concentration. Concentration. See students, this is a chemical reaction. Suppose H2 plus I2 is in equilibrium with 2HI. If I increase the reactant concentration, or any one reactant concentration, equilibrium moves towards product side. So increase of concentration of reactant shift the equilibrium towards product side. If you want to get more yield of HI, you have to increase the concentration of either hydrogen or iodine, or at a time both you can. Okay, so increase of concentration, it is very simple students. Increase of concentration of reactants shifts the equilibrium towards product side. Product side. So on increasing the concentration of H2 or I2, formation of HI will be more. Leads to the formation of forward increase reactant concentration. If you increase, the equilibrium moves towards product side. Product or decrease of the concentration of reactant moves reaction towards left hand side or reactant side. Shifts the equilibrium towards reactant side. Understood students? If you increase the concentration of reactant, this side stress is more. To overcome the stress, they move opposite side where the stress is less. That is only effect of concentration. In examination, they will give the concentration. They will give the conditions like any one reactant concentration. They will give like H2 on adding extra concentration of H2 and adding extra moles of hydrogen. Equilibrium shifts towards. Forward reaction is favorable or backward reaction is favorable. Formation of HI is favorable. Under which conditions, like that they ask questions. So formation of HI is favorable only when the increase of concentration of either hydrogen or I2 or both reactant concentration. And sometimes indirectly they are asking, volume of No, that I will do in applications. Let it be here. Not on water. So to get more yield of product, we need to increase the concentration of reactants. Increase of concentration of reactant favorable towards product side, or increase of concentration of products favorable towards reactant side. Opposite reaction takes place. That is only the effect of concentration. Next one, effect of temperature. Temperature effect. Temperature. Temperature. So you know there are two types of reaction. One is endothermic reaction, another one is exothermic reaction. Endothermic reaction and exothermic reaction. In endothermic reaction, what happens, students? Reactants absorb energy. After absorbing energy, reaction will proceed. Okay. Otherwise, you can write this is endothermic reaction. Endothermic reaction. Sometimes they are giving delta H positive also, students. Here delta H, enthalpy. I think you are not very familiar with the enthalpy and all. Delta H, for timing you remember that word, enthalpy. If it is positive, some value they will give. Some value they will give. You no need to remember the value and all. Just positive sign is there in front of the value, or negative sign is there in front of the value. You have to check. If positive sign is there, endothermic reaction. Negative sign is there, exothermic reaction. Delta H is positive for endothermic reaction. Next one, A plus B is in equilibrium with C plus D. Suppose here one more thing, here all I will do. Forward reaction is endothermic. Reverse reaction will be exothermic. Very good. A plus B plus Q. Forward reaction is endothermic, so backward reaction is exothermic. Here delta H value is negative. So here endo means, you remember students, entering, En. Entering starts with En. Here also endothermic starts with En. Heat is entering. After entering the heat only reaction is proceeding. So endothermic reaction. Exothermic, exit. Giving out or coming out. Okay. Exothermic. So exo reaction also start with Ex. Like that you remember. Endothermic reaction, heat. Endothermic reaction is proceed by absorbing heat or by taking heat. Endothermic reaction. Endothermic reaction is proceeding by gaining heat. So here exothermic reaction, heat is giving out to the surroundings. Is giving out after the reaction. Now effect of temperature we'll see. Endothermic needs extra heat. So when we increase the temperature, it is favorable for endothermic reaction. Endothermic reaction. Exothermic reaction, already in the reaction heat is evolving. Again if you give heat, the reverse process takes place. So for endothermic reactions, increase of temperature is favorable. For endothermic reaction, increase of temperature is favorable because it needs heat. If we increase the temperature, reaction will proceed faster. Okay. If the reaction is endothermic, giving heat is, increase of temperature is favorable. Write down this point. Increase of temperature is favorable for endothermic reactions. Next one, decrease of temperature is favorable for exothermic reactions. Exothermic reaction. X plus Y is in equilibrium with Z. Delta H is equal to minus 19.5 value I can't write. What happened to this? Okay, delta H is equal to, I am taking minus Q. Delta H is equal to minus Q. So from this reaction we got to know this is exothermic reaction. This one is exothermic reaction. So to get more yield of Z, what we have to do? Decrease of temperature. Decrease of temperature to proceed forward direction more effectively. Decrease of temperature is favorable. If it is plus, increase of temperature. Okay, like this they are asking. For exothermic reactions, decrease of temperature is favorable. For endothermic reactions, increase of temperature is favorable. Easy only, students. Next one. Next one. Effect of pressure. Pressure effect. Pressure effect. Here, do one thing, students. Remember Boyle's law. You know Boyle's law. P is inversely proportional to volume at constant temperature. For time being, you just remember. Suppose if I increase the pressure, equilibrium will shift towards where the volume is less. Where the volume is less. You know, volume is directly proportional to N. Volume is directly proportional to N. So, decrease the volume, I said no. Decrease the volume, in other words, what we can say? Decreasing number of moles side. Decreasing number of moles side. That too, gaseous number of moles side. Okay. Increase of pressure favorable towards the decrease in number of moles of gases. One sentence if you remember, or Boyle's law if you keep in mind. Just only for understanding purpose I use this one. Here it is not required only. Okay, write down the pressure effect. Increase of pressure favors decreasing number of moles, gaseous number of moles, right? Decreasing number of moles. Gaseous number of moles. Example I will take N2 gas plus, if I explain with example, you can understand it better. 2NH3 gas. All are gases only. See students, reactant side how many number of moles are there student? Gaseous number of moles, this is 1, this is 3. Total 4 moles of reactants are there. Product side how many moles? Ammonia only 2 moles. Okay. Now if I increase the pressure, equilibrium moves towards less number of moles side. Which side less number of moles are there? Product side, isn't it? So forward reaction takes place. Formation of ammonia is more favorable. Got it, students? Effect of pressure. Is it clear?
Yes, sir.
Okay. Increase in pressure moves towards where the number of moles of gases, where the number of gases number of moles less. Okay. Now for this system, if I increase the pressure, ammonia. By here, less number of moles are there. Less number of moles. If I decrease the pressure, reverse reaction takes place. Equilibrium moves towards reactant side. Next, N2 plus O2 gas, both are gases on strings, is in equilibrium with the 2NO gas. Could you tell pressure effect students? If I increase the pressure, which side equilibrium shifts? Here, see students, product side. These are the products, right hand side. These are the products. These are the reactants. Here, how many moles are there? Only 1 mole. Product side, how many moles are there? 2 moles are there. This one is gas. This one is gas. 2 moles. If I increase the pressure, PCl5 side it shifts. Less number of moles side. Every time left side reactants you consider, right side products you consider. Number of moles of reactants is equal to 1. Number of moles of products is equal to 2. Increase of pressure shifts the equilibrium. PCl5 towards PCl5, less number of moles side. Understood, students? Where the number of moles are less, that side equilibrium shifts. So to get PCl3, PCl2 more, Cl2 more, decrease of pressure. This is about effect of pressure. So I can complete it. Effect of concentration on Sorry, here I wrote mistake. Concentration and effect of temperature and effect of pressure. Effect of pressure. Next, last one, catalyst. Students, catalyst does not affect the equilibrium because it increases both forward and backward reactions. It increases the both forward and backward reactions. So catalyst effect is nothing here. Since it increases both rate of forward and backward reaction. Since it increases rate of both forward and backward reactions, and it helps to attain equilibrium faster. Only so much. At least does not. So four factors we finished in that. First one is effect of concentration, effect of temperature, effect of pressure, and catalyst. Concentration of reactants, if you increase, equilibrium moves towards product side. Or concentration of reactants, if you decrease, equilibrium uh, favors towards reactant side. Okay. Next one, temperature effect. There are two types of chemical reactions. One is endothermic, another one is exothermic. In endothermic reactions are favorable by increasing temperature. Exothermic reactions are favorable by decreasing temperature. To identify exothermic and endothermic, most of the time they are giving delta H values. If delta H value is positive, endothermic, delta H value is negative in exothermic. Accordingly, pressure effect you can find, you can write. Next one, temperature effect you can write. Next one, pressure effect. I had given one simple technique, Boyle's law, you remember. Boyle's law, according to Boyle's law, P is inversely proportional to volume at constant temperature. Now, if you increase the pressure, equilibrium moves towards where the volume is less. Where the volume is less means where the number of moles are less. The moles are less. In pressure only, you observe carefully. Okay. Which side number of gaseous moles are less, that side equilibrium shifts. Okay, I'll given some example. If number of moles of reactants and products both equal, then equilibrium does not affected by pressure. Pressure does not affect the equilibrium. Am I any doubts in this? And catalyst also, there is no effect of catalyst on equilibrium. It increases both forward and backward reactions equal speeds. Shall we do one few applications with this concept, this equilibrium chapter over? And one small topic I left, nothing is there. Homogeneous types of equilibria. Types of equilibria. Easily can understand, nothing is there. There are two types. One is homogeneous equilibrium. Another one is heterogeneous equilibrium. Homogeneous means here reactants, products, if any catalyst is there, that must be even catalyst must be in the same phase. same phase. Example, N2 gas okay, at least you don't use here. Reactant products we'll see. Otherwise, I'll take one more example. Ester hydrolysis or hydrolysis of ester. C2H5. I think you may be knowing this reaction in the presence of H plus. This one is aqueous medium only. This one is in liquid state. This one is in liquid state or aqueous medium. It gives acetic acid and ethanol. All are in liquid state. This type of equilibrium symbol equilibrium is called homogeneous equilibrium. All the reactants and products must be in same phase or state. Homogeneous equilibrium. Next one, heterogeneous equilibrium. Opposite to this. They may not be in same phase. Example, CaCO3 on decomposition is CaO plus CO2. Here CO2 is in gaseous state, CaO and CaCO3 both are in solid state. So they are not in same phase. They are not in same phase. This is an example of heterogeneous equilibrium. Heterogeneous equilibrium. So we'll solve some questions, students. Applications. Yes, vaporization is also heterogeneous process. D1, correct answer. Very good. Correct example. H2O liquid to gaseous state, no. So their states are changing. Even condensation also. One state is changing to another state, right? Next. Here there is one reaction, one problem. Problem is equilibrium reaction they have given N2 plus sorry N2O4 is in equilibrium with 2NO2 gas. Concentrations of N2O4 gas and NO2 gas at equilibrium are at equilibrium are 4.8 into 10 to the power minus 2 and 1.2 into 10 to the power minus 2, 1.2 into 10 to the power minus 2 mole per liter respectively. Respectively. What is the value of K? Value of Kc. First, how to write, students? This is the given reaction N2O4 Yes, is in equilibrium with 2NO2. Yes. Kc is equal to concentration of NO2 per 2. If any coefficient is there, that will be raised to the power N2O4. Here NO2 right now. We have concentrations of NO2 and N2O4. NO2 how much? Second one is NO2, right? 1.2 into 10 to the power minus 2 by 4.8 into 10 to the power. Here all to the power 2. Tell me students what is the answer? Simplification you do, you will get answer. Otherwise for timing I will only tell. 3 into 10 to the power minus 3 mole. Kc no unit. You just like this. Oh, no, unit will be there because it depends on equilibrium. Mole per liter. Mole per liter. If number of moles both sides if they are equal, no, then there won't be any unit. Understood, students? How to solve the problem? They are giving the reactant concentration, product concentration. They are asking you to find out Kc. Next one. One more problem. Consider the equilibrium, or consider the reaction equilibrium 2SO2 gas 2SO2 gas plus O2 gas is in equilibrium with 2SO3 gas. Delta H is equal to minus 198 kilojoule per mole. Kilojoule per mole. On the basis of Lee-Chatelier principle, the condition favorable for the forward reaction is lowering the temperature as well as pressure. No, you only tell with respect to pressure and temperature. I don't want to give options. Delta H, they have given negative.
So condition favorable for
Formation of SO3. Favorable for formation of SO3 means forward reaction. No, it is not endothermic. No. That's my correct answer. Delta H value is negative, right? Negative means forward reaction is exothermic. Exothermic means With respect to temperature, which is favorable? Decrease of temperature. Tripti correct answer. And here product side number of moles are less. Number of moles is less. Product number of moles is less. So increase of pressure is favorable. One more thing, increase of concentration of SO2. If I write in square bracket, it is concentration. Increase of concentration of SO2 or increase of concentration of O2. Both favorable towards formation of SO3 or forward reaction. Aishwarya, got it? Third application. What is the equilibrium expression? Means equilibrium constant expression for P4 solid plus 5O2 is in equilibrium with the P4O10 solid. So here sending answer is difficult. I'll give the options. Just you send option only. Kc is equal to P4O10 by concentration of P4 into concentration of O2 power 5. B option is Kc is equal to concentration of P4O10 by 5 into concentration of P4 into concentration of O2. C option Kc is equal to O2 power 5. D option Kc is equal to 1 by O2 power 5. Tripti, correct answer. Kc we have to find out, Tanmay. For this reaction, Kc we have to write. Kc we have to write. Only Tripti is correct. I told you other day, Aniketa, you are also wrong. I told you other day, solids will take 1. For solids, concentration will take it equal to 1. While writing equilibrium constant, Kc or Kp will consider only solids, not liquids and gases. Got it, students? So this one is correct. Kc you can write as it is P4O10 by concentration of P4, concentration of O2 power 5. This will get cancelled since solids will make it unity. We'll get this. Clear, students? All these things I explained in first class. Since you are neglecting chemistry now, you are not revising. Yesterday in visa interview also, I could observe our CFAL people, mostly our students, they they selected only physics maths. Next one more reaction, one more application, fourth one, CO for the reaction. Cl2 gas. Kp by Kc is equal to Kp by Kc is equal to, you know, the relation Kp is equal to Kc into RT power delta n. Other day we did delta n. So now delta n, yes, is nothing but sum of the number of moles of ACS products minus number of moles of ACS reactants. Number of moles 1 minus 1 plus 1 2. How much will you get, students? Minus 1. Yeah, reactant side 2 moles are there. Product side only 1 mole is there. Now Kp is equal to Kc into RT power minus 1. Now they asked ratio, right? Kp by Kc is equal to 1 by RT or RT power minus 1. Is they asked. Easy it is. This type of questions you prepare. And they are asking in JEE mains also, they are asking this type of questions. Simple. Done, students? Next one. One more problem. It is applicable like characteristics of equilibrium constants are there. First, the four in the beginning, I gave 4 properties based on that. Equilibrium constant for the reaction. Equilibrium constant for the reaction. Reaction N2 gas plus O2 gas is in equilibrium with 2NO gas at temperature T is 4 into 10 to the power minus 4. Next question is the value of Kc for the reaction. Kc for the reaction. Reaction NO gas is in equilibrium with half N2 gas plus half O2 gas. See, students, for this reaction, we have given equilibrium constant. N2 gas plus O2 gas is in equilibrium with 2NO gas. For this, what is the equilibrium constant? Kc 4 into 10 to the power minus 4. 4 into 10 to the power minus 4. They are asking for the reaction. You see here, NO gas is in equilibrium with half N2 plus half O2. For this Kc dash, how much they are asking. If you observe, second reaction is the reverse reaction of first one. Yes or no? In first reaction, product is here reactant, NO. Okay. Now Kc dash is equal, equilibrium constants of forward and backward reactions are reciprocal to each other. Yes or no? Kc dash is equal to 1 by Kc. By doing reciprocal, we will get. Next, here they multiplied with one factor. What is that factor? 1 by 2. 1 by 2. So that will be raised to the power of. So now, in order to get Kc dash, what you have to do, students? 1 by 2 means square root of 4 into 10 to the power minus 4. So here square root of 4 is 2 into minus. How much will get students? 50. Kc dash. Understood students? Observe the relation between given reaction and our one more to which we are going to find out that reaction relation. KP-KC relation you just find out. Come on. In this chapter, important things are KP-KC relation and characteristic properties of equilibrium constant, characteristic properties of equilibrium constant, and Lee-Chatelier principle applications already I told you know. Lee-Chatelier principle, all the application factors are important, and on how to write the equilibrium constant. While writing equilibrium constant, ignore solids and liquids. Ignore solids and liquids. Only gases you have to write. Product concentration by reactant concentration. In that concentrations, you have to include only gaseous reactant. Only gases you have to include. Next one, they make you Kf value and Kb value. They'll ask you to find out Kc. In that case, what is the formula, students? Kc is equal to Kf by Kb. And they'll give no units are there, students. Suppose here, very good question you asked. N2 gas plus 3H2 gas is in equilibrium with 2NH3 gas. Units of this equilibrium constant, if you want to write, Kc is equal to NH3 whole to the power 2 by concentration of N2 into concentration of H2 whole power 3. All are concentrations only, you know. So what I am doing, no, concentration power 2 by concentration power 1 and concentration power 3. You know, concentration is nothing but N by V. N is nothing but mole. Volume unit is nothing but per liter. Okay. Per liter. Substitute here mole per liter whole square by 1 plus 1, 1 plus 3, 4. Mole per liter whole to the power 4. 2 times it will get cancelled. This and this one. So what we get, students? Mole per minus 2 liter square will get. Liter square. It depends on reaction. From equation to equation, equilibrium to equilibrium will change. Equilibrium constant. If see here, N2 gas plus O2 gas is in equilibrium with 2NO gas. Here no units. Here no units because here 2 moles, here 2 moles. If delta N is equal to 0, no units. Remember, students, no units. If delta N is equal to 0, no effect of pressure. No effect of pressure. If delta N is equal to 0, Kc is equal to Kp. All these things. By knowing one single term, you can relate all these things. Delta N is equal to 0, no units of equilibrium, no units means no dimensions for equilibrium constant. If delta N is equal to 0, no effect of pressure on equilibrium. If delta N is equal to 0, Kp is equal to Kc because Kp is equal to Kc into RT power delta N. Here anything power 0 is equal to 1. 1 into Kc is like this. From this. So, in which among the following, in which Kp and Kc are equal? Among the following, for which system no units are dimensionless equilibrium constant. Equilibrium constant. For among the following which equilibrium does not affect by pressure. Like this, they are asking. Okay, students, these are the topics and applications are prepared from chemical and chemical equilibrium. Thank you, students.